Okay. So that's pretty great. We've gone from like a pretty limited set of information, just those surface observations and a couple drill holes, and we've actually built 2 domain models here. Even if they're not overly confident at depth, it's still a starting point, and it's still a hypothesis that we can test by drilling, by doing more drilling at depth. Alrighty, where do we go from here? Questions to think about now that we've put together 2 domain models is that we've got a few boundaries here that don't perfectly line up, right? So play around viewing these a little bit by ISO values. If I view, say, just the mill rock volume, right? And I color this by fault model. I'm going to change the colors on these to make them a bit clearer, because I don't like how I've got one litho color that's green and the fault footwall that's also green. So I'm going to change this to, I don't know, purple on the footwall and like dark red on the hanging wall. So here's my 2 fault domains, and the blocks I've colored here just belong within that mill rock unit. So really I could further subdivide the mill rock into 2 units, but do we think it would be useful to do that? I guess we don't know yet. Guess we brought in the geochem yesterday. So if anyone remembers where those higher grades lie, do we think it would be useful here to break this down into 2 further domains? And what would our criteria be for doing that? Just the spatial location on the surfaces that we used, or is there anything else that we might want to look at to see if we can find other correlations? A little bit more coffee.
I don't have any idea.
Got to keep looking. That's the thing. The next thing here is to bring in some more information we can use to figure that out. Yeah. So let's see. I've still got the stuff I ran through quickly yesterday. The other geochem. So let's bring in the drill holes. If you already have them in here, that's great. From what you were working on yesterday, you can turn them back on. Maybe we'll start here just by coloring them by the geology, because it always looks kind of neat seeing our geology line up with a nice model. And just a note, if you started fresh this morning and you don't have these drill holes, please go ahead and bring them in by looking in. You can find the collar, survey, and geology files under exercise 13. Nope, exercise 14. These ones cannot be dragged and dropped. For these ones, you do have to go through the file import, ASCII drill holes, specify your collar file, which will be in your exercise 14 folder, collar, survey. The geology table is an interval, but we're also going to need, yeah, you can go ahead and bring those in, click OK, and click OK through the next steps to bring those drill holes in. Then once you've done that, and I'll just clear all this stuff out to make it look like I'm updating these. Once you've brought them in and you can plot the geology up like that, just by walking through those windows, you can update that existing drill hole group by appending the geochem and mag tables to it. So with a drill hole group already in your project, tick on update existing drill hole group, pick it from this dropdown. You don't need to select the collar or survey file again, but then you can pick that interval button and go into your exercise 18 folder and pick geochem, which is an interval table. And then in point log files, pick mag, which is a point log table. Click OK, go through the importer windows again, and that will bring in your GeoChem table and your mag table. Does anyone need to take a closer look at the drill hole importer? Didn't want to walk through all those steps in depth again, but if anybody needs to bring those drill holes in, you're struggling, having any struggles with the importer, let me know and we'll go through it together. Okay. In that case, we'll now see, after updating that drill hole group, we'll see GeoChem and mag in our list of interval tables. And the idea here now is we want to look and see, particularly in the mill rock area. So in these ISO values, this volume I've still got shown on the screen. We want to look and see if we can find some relationships between the geochem or maybe the magnetics data that can help us break down this unit. Maybe it correlates with the intersection there between the fault domain and the litho domains. Maybe it needs to be broken out as a new one. Maybe we'll have to model a new surface and construct a new model and break out another smaller domain. So in order to do that, first place we should probably look is at our economic minerals, something like our copper, and color your drill holes by copper by ticking on the CUPPM button. I'm going to make my data table here a little bit bigger because what I'll want to do is start inspecting some of these intervals and checking on my data colors panel that I've got them scaled in a way that kind of makes sense. So I can see all these green values. If you don't see a pretty consistent color through here, through the top of the hole, you might want to remap your color settings. So if you've just brought these in fresh, it'll probably look something like that. And looking down that drill hole trace, just looking at the color, it looks like we've got a lot of high grades just right at the top of the drill holes. That's not real, right? Clicking through these, I can see that these CUPPM values are really just between 200 and 300. And these ones down here are only a little bit lower, around 100. So that's not the best use of this information. We're not looking for differences from 100 to 300 ppm. We want to look for the really high values, something like 40%, 40,000 ppm. So to do that, we'll want to remap our color settings and maybe set our maximum scale here to something like 500. That way we're seeing a color ramp from 0 to 0.5%. Everything 0.5% should light up. That's where we want to look. Click OK there. Now I can still see there's a contrast, and it certainly seems to line up with moving from our hidden formation into our mill rock formation. Don't see anything too special coming out of that. Let's take a closer look by cutting a section on one of these drill holes and walking through a few sections. So to do that, we can view from the top, right? View from the top, from that toolbar button, and use the X key and draw a line just along the whole trace as we see it. We can look at either FFS 49 or 46. Those are going to be the best places for us to look to start. So I'll do that. I'll press X, and I'm just drawing a line right through that hole. Taking my key off, my finger off the mouse button and the X, and I can see that slicer plane drawn. Now it hasn't sliced my model because I'm reusing an existing slicer here. Right? And when we create a new object, slicers are not applied to it if they already exist. So to apply that slicer, make sure it's applied to everything. Right click on your workspace, click on slicer, and find the slicer you're using. Make sure it's applied to everything. The other thing you might see is that you've removed the front or removed the back. To change the slice type so that we're looking at a thickness slice, make sure that slice is picked got that slicer picked in your objects tree, look down to the bottom section there and tick on slice and set it to a thickness. That seems appropriate for what you're trying to view. So this is good enough for me. I can see this drill hole. I can see I've got like a hollow section of these ISO values, and I don't know that that's terribly useful. So what I'll want to do is, instead of viewing by ISO values when I'm looking at a section, I'll want to view an arbitrary section that's aligned with my slicer plane. So I'll click on arbitrary section and align it with the slicer that I'm using. And the other thing we might want to do here is turn the transparency up just a touch so we can see the whole drill hole moving through that plane. And we might even want to adjust the slicer location just a bit to kind of view that drill hole just in front of it so we can really see what's happening. So you can change your move distance, to maybe something much less, and just walk just a little bit, because I want to see that really high copper value plotted against the plane that I'm looking at. Now I'll reset my viewing angle here. Now I can see where that lines up. Okay, but I'm just looking, the arbitrary section doesn't really filter by ISO value. And what I really wanted to check is if the copper value has any association with the domains I've broken out. I can see it's in the fault hanging wall, but how does it compare to the lithology model? Is it inside the mill rock or the hidden unit? We can find that out by playing with some of our visualization settings on our block model, right? We could just flip back and forth. Just got to do this quick. If you do this quickly enough, it looks like a flip book. Or you could try data blending. Slide it back and forth like that. You get it just right. You can see the breaks. Or, we could also turn the surfaces on and see where the surfaces intersect that plane. I could turn on all three of them and rotate around just slightly like that to see where it lies. Okay, what do we think now? Take a look at that. Walk through to your FFS 46 section and see if we can associate maybe breaking out that subdomain if it's useful in identifying some volume that can contain grade. Might not be perfect, right? Even within the halo, like the halo that we're looking in, we're still going to find a ton of waste. We're looking for a very small volume of rock within a larger volume, within a larger volume, within a larger volume. So it's just kind of an iterative process of chipping away at the bad areas. Right, so the one other thing I didn't talk quite about here was walking through those sections a bit further and taking a look at other drill holes. So I'm just going to reset my view to look at the drill hole here. I'm pressing and holding X, and I'm seeing this little green guy appearing on my screen. When I hold X and I see that, I can scroll through sections with the mouse wheel. And I want to scroll, I'm scrolling back to move forward, because I want to see where that FFS 46 is. And that guy sits right on that boundary zone between mill rock and hidden, and within that little subdomain we were looking at. Okay, what do we think now? It might be useful to break that area out and investigate that a little bit more closely instead of wasting our energy on everywhere else all around here. Yeah. But let's see if we can find any more associations. We've got some more geochem. We've got a set of oxides. We've got those two other metals. We've got lead and zinc. So we can look at these two sections. Just fix my view again because I was rotating it a little bit. And try leaving copper, the color set to copper. Try, oh, seems like I already had, that's why my things all look a little bit offset. Yours may not have looked like mine. I had my log scaled this entire time by zinc. Doesn't look like there's a really strong association with zinc here, but we could try scaling by copper. Looks kind of constant. Like there's a bit of elevation here, but it's not the level of change there isn't quite as strong as in the copper. Or of course we could just try coloring by some of these other logs, but if we do that, so I just colored by zinc, we'll want to double check that color clipping too. So we're seeing the same thing here as we saw initially in the copper. If we've got an equal area color mapping, it looks like just this whole area is high grade. That's misleading by color plotting. So we'll want to fix that scale to go up to, let's see, I'm taking a look at the mean at around 1,000. Since those outliers are so high, I probably want to drop this a little bit below the mean. So maybe cap this one at 500 ppm as well. And there we can see, you know, this area is not as high graded as it appears. And really we're looking for that same 500, 750. Really we're looking for that same area there as where we're seeing the higher copper values. And we'll probably find the same thing for lead. If we remap this one to, just going to throw a number out there at 800. Yeah, that shows it up pretty easily. But to see a bit of the variation above and below, we can turn that down. There you go. And I'll turn off scaling just because it is making my drill holes look a little bit funny, especially when I don't remember what I've got them scaled by. All right. Let's take a look at the those oxide geochem now and see if we can put together an alteration model. Maybe we can fit an alteration model that more closely matches the full extent of this subdomain we're looking at, that we can use to target the target a mineralization extent. Rather than looking at all these values individually, what we did yesterday was combine them all into an alteration index, that Ishikawa index. So if you didn't do that yesterday, we can do that with a script on the drill hole. We'll do that by right-clicking on FlinFlon DDH, go to script, and filling out this script. Leave that up there on the screen for a minute. If it's not, it should look like, just because that text might be a bit small, I'll grab that picture and make this a bit bigger for you. So it should be 100. In this text, it's just not the same as those properties. It's what you see in the script needs to be, like the variables that we're using need to be exactly the same as the property names. So you'll need to make sure that, you know, you grab this, you can double click on it, copy that text from the name and paste it in. And that will give you the exact one. You can see if you're actually picking the right property by seeing that in the script plotting that the name of the variable is bolded. And if you're not seeing that the name is bolded, you may need to go to the property table dropdown and make sure that you're working in the geochem property table. I'm not going to run this again because I've already done it. And I'll leave that there. I think actually, you know what? I dropped the a picture. Oh, it was in the meeting from yesterday, so you won't see it again. But just so everybody can see this one, if you're coming back to it later, it should look like this. There we go. And that gives us, calculating that alteration index will give us a rough idea of how strongly altered that sample is that we're looking at. So if I color by alteration index, and I've already fixed my color scale. When you do this first off, it might be set to equal area mapping. It's going to give you something looking like that. You do get a good idea of where the higher values are. Let's turn off scaling on all these. But I'm going to remap this to linear from 0. The scale is from nearly 0 to 100. And then I'm going to scale by that index to see what's going on in here. So I can see that there are higher values on this drill hole in that subdomain we're looking at. Let's see how that other drill hole compares, FFS 49, by rolling our section back, scrolling forward to move back and checking out that other drill hole. Press X, roll forward to scroll back. And there's 49. Turn off the log scaling just to see the colors, and we see the same thing there. So that very closely corresponds with that little region in between the fault hanging wall and the hidden mill rock contact. So that makes it look like a likely region we should spend some more energy on. We haven't proved any relationship. We're just observationally seeing that grade seems to exist here within this area. That gives us a next step in picking a target. Let's investigate this more. Maybe the grade is associated with something else that happens to, just by chance, happens to exist in the same place we're seeing this alteration. We haven't proved a relationship. We've just observed an association. Okay, so to move forward with that, let's intersect our fault domains, that hanging wall fault domain and our mill rock domain. We'll break that out and look at that more in isolation. We can basically, we're saying, you know, we're interested in this central chute, but we don't really care about this now. We just want to look at this. Let's keep in mind while we do that, that the accuracy of these domains is based on the surfaces we modeled. So they're still subject to all the uncertainty we had about those surfaces when we modeled them. Something else to keep in mind here is that we didn't remodel that F1 surface. We never adjusted that with drill hole picks because we had no fault intercepts on our drill holes. So in reality, we don't have any extra certainty where the drill hole is piercing that surface. This is something we encounter all the time in practice when some structure that ends up being significantly associated with mineralization is ignored because that structure is not recognized. Sometimes we're looking at historic drilling, 25, 50 years old, and we have to go back and find out that it's not useful in proving up a relationship that we've only discovered more recently. But for now, it's simple enough just to try breaking this out with the understanding we have. We'll use that understanding to do some more targeting. So to do that, we've got the two properties, and basically we want to make a third property here, right? Something that just says inside here or outside. We'll call this our alteration model because it seems associated with those higher alteration index numbers that we saw. So I'm going to turn off my slicers and go back to a full 3D view here by unchecking tools. And I'm going to turn off my surfaces by turning off the container group and then turn off the drill holes. I'm also going to turn off data blending and put my transparency down to 0. Essentially, the way we're going to do this is with a script, another script, and it's going to be a conditional statement asking, I want, give me a yes wherever I see that fault hanging wall, that the fault model says hanging wall, and that the litho model says mill rock. That's the overlap in our region. To visualize that, turn off the arbitrary section, turn back on those mill rock volumes, and look here. If I look at any of these red cells now, I should see that litho model. Litho model is mill rock, and fault model is fault hanging wall. That's the area I want to break out, and we're going to call this our alteration, our strongly altered domain. So you should be able to pick any of these blocks. In my case, they're red. You might have them in a different color. And I should see that litho model says mill rock and fault model says fault hanging wall. So we kind of understand conceptually just that we're taking two existing classifications and looking for where they intersect or overlap. Just before I run the script, or do you want to take a closer look at how we actually just break that inside region out?
Can we take a closer look?
Yeah. So if we take a look just at the fault model, I'll put on a section here and turn off the ISO value. If we take a look just at the fault model, we've got two very broad domains, right? For me, purple and red. On their own, not overly useful. I might know that my mineralization is on one side or another side, but the volume is so large, I need to find something else associated with it to further narrow down the area I want to investigate. On my litho model, on the other hand, I've got 3 units. So here in this case too, I may have already identified that I'm only interested in looking in the yellow unit. I'm not interested in looking at green. But again, that's still like, you know, a fairly wide, yeah, there's my yellow unit. That's still a fairly broad region to investigate. And I want to look for just tools I can use to chip away at this spatially, so I can shrink my search area. To do that, we can intersect these regions by looking at both classifications and chopping one away. So if I've got the yellow, and I know that it's subdivided by this fault, then I can say, I just want to look at the material in yellow on the hanging wall of the fault. I don't want to look at the material on the foot wall. The association there that we observed with the alteration and with the grade distribution is that it is either sitting on this yellow-green contact or in the yellow contact. We also saw that it doesn't propagate through that fault surface. So that tells us that if we want to focus our energy where we're likely to see another mineral occurrence, we should shrink our search area to just look at this one, at this area in here. To set up the targeting, we're going to need some kind of a spatial categorization scheme to say, I want to look at this volume of rock. With the yellow alone, I don't have that restricted as much as I would like. So what we'll do is look just for the region where both we have yellow and we have red. That shrinks our search surface and gives us a higher likelihood of making another hit, based on the assumptions that we've made in breaking all these regions out. We're still uncertain about the spatial location of these surfaces, and what we'll be doing is testing both our interpretation of where these regions are and whether our idea of we should find more mineralization here is actually true. Did that help a bit? I'm kind of going around. I'm trying to trying to approach this in a few different angles, but like ultimately the idea is we've got this entire volume. If I turn on like all the classes, we've got this entire volume of rock that we need to investigate. And it's not going to be cost effective to just try plotting this as a grid. Cheaper at surface for sure, but when we start drilling, we're paying maybe hundreds of dollars per meter for core recovery. So we can't just drill off this entire region and not be selective about how we set up our targeting scheme. So the idea is to try to find associations we can use to exclude areas from our search. Yeah. Oop. Mill rock. Right. Okay. Our alteration is going to be basically another domain model. We'll have a strongly altered zone in red, and we'll have unaltered zones on the hanging wall side of that and the full wall side of that. We can set up a script to do that. That will look like, call this alteration model. And we'll say, this is going to look like it's a conditional statement. If condition is true, then do this. If the condition is false, then do this. So in this case, the conditions we want is that fault model, and I'm going to double click on this to go like almost like I'm renaming it, but I'm just going to go Control C to copy that text and then paste it in here. That's recognized as an existing property, and I can see it in bold. And the symbol I want to use to compare this to another value is equals equals. So I got fault model equals equals, and I want it to match F1 hanging wall. I'll go double quotes, F1 underscore hanging wall. That needs to be exactly the same as the name that you have for that property in the data colors. And that's evaluating whether fault model is equal to fault1 hanging wall. That on its own will just basically reproduce the property you already have. The fun part here is intersecting these and doing one and then the other. We can do that simply by saying and. So fault model equals equals fault1 hanging wall space, and I want litho model. Copy the text again, double clicking on it and Control C copying. And litho model, and again that's bolded, space equals equals. That's bolded to show that it's recognized that I'm picking this existing property. And I want my litho model to be mill rock. So equals equals space and quotes mill rock. Okay. So running it just like this will give you another, basically a masking property. It'll return true where these conditions are true, and it will return false where these conditions are false. We could do it like that, but it's a bit more valuable to give this, to label those domains with something meaningful. So rather than just leaving it like that, I've hit space again and put in a question mark. The question mark is the value that we want returned whenever these conditions are true. So question mark, go quotes, and we'll put in highly altered, close quotes. So wherever both those conditions are true, we'll get a classification that says highly altered. Then a colon for otherwise, and we'll call this one unaltered. So what I'm going to do here is just take a screenshot of this and zoom in on this so we can all see it, because the text is a bit small. And then just to recap here, We're evaluating two of our existing properties. We've broken out two sets of domains, a fault model, and we're interested in where we're on the hanging wall of our fault, and we've broken out a litho model. And we're interested in where the litho model equals mill rock. So to convert that into a script that the application can understand, we'll take fault model, see that it's bolded, see that it's been recognized as an existing property on this object, compare it with equals equals. Where is it the same as F1 underscore hanging wall? Make sure you get the double quotes in there, or it won't recognize that it's the name of the class. And where litho model, also bolded and recognized, equals equals, double quotes, mill rock. So wherever both those conditions are true, which is the question mark is for true, we want to create a class that says this is our highly altered zone. Wherever those conditions are false, colon, we'll call it unaltered. There are other software applications where you can do this without running a script. In GA, we do this with a script. Many of our other tools have kind of grown out of things people have just scripted. So I guess I want to ask, do we feel comfortable with how I've kind of broken out the syntax and how to use the symbols, the comparison, equals equals, the question mark, the and statement? Yeah, we feel good about this. Okay. If you're playing around with this, and you'll find way more uses than the stuff that we've covered here. You can find more information on the what syntax is actually used by clicking on the help button. So if you're trying to do this again, you're not getting the stuff you expect. One common one is that I've just put one equals instead of the double equals. You can find the help in that little blue question mark there beside it. Okay, so since we've done that, I'm going to click apply just to leave the box open. And before I close it, I'm going to double check that I got the results I wanted. So there's my alteration model property that's been created. I'm going to leave the ISO values on. I'm just going to change the color of the ISO values because I want to see this, just this volume in its own distinct color. And it looks like I got what I wanted. So that's just been broken out to blue and red. And I think I'm actually going to flip those because to me, strongly altered feels red instead of blue. And I'll put this one to a slightly different blue than we've been using before. There we go. Did that work for everyone? Are you seeing the same kind of thing that I'm seeing where we've got that one region just in the middle there that's now kind of existing in its own domain on the same model?